Okay, so let's tackle question 3, part A, part 1. In this question, we're required to prove the identity tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. This is not a difficult result to prove, but you do need to be able to recall the relevant trig identities, and you must be comfortable manipulating fractions. I'll start from the left-hand side and derive the right-hand side. Let's go. Since tan x is equal to sin x on cos x, it follows that tan A plus B is equal to sin A plus B on cos A plus B by replacing x with A plus B. Recall that sin A plus B is equal to sin A cos B plus cos A sin B, and that cos A plus B is equal to cos A cos B minus sin A sin B. Hence, sin A plus B over cos A plus B is equal to sin A cos B plus cos A sin B over cos A cos B minus sin A sin B. But what do we do now? Well, notice that the first term in the denominator of what we want to get is 1. We can get that 1 by dividing cos A cos B by itself. Obviously, we can't just jump into the fraction and divide cos A cos B by itself, since that would change the value of the fraction. However, by strategically multiplying the whole fraction by 1, where we put 1 equal to 1 on cos A cos B all divided by 1 on cos A cos B, which doesn't change the value of the fraction, we get the following. Multiplying the numerator by 1 on cos A cos B, we get sin A cos B plus cos A sin B over cos A cos B, and multiplying the denominator by 1 on cos A cos B, we get cos A cos B minus sin A sin B over cos A cos B. Let's look at the numerator. We can break up that fraction into sin A cos B over cos A cos B plus cos A sin B over cos A cos B. Looking at the denominator, we can break up that fraction into cos A cos B over cos A cos B, which is what we wanted to get. This is why we multiplied the entire fraction by 1. And we get that minus sin A sin B over cos A cos B. Back in the numerator, the first term simplifies to sin A over cos A. The second term simplifies to sin B over cos B. And back in the denominator, the first term simplifies to 1, which again is what we wanted. And the second term simplifies to sin A over cos A multiplied by sin B over cos B. Recall that tan A or tan x is equal to sin x over cos x. So it follows that sin A over cos A would get us tan A as the first term in the numerator, and sin B over cos B would get us tan B as the second term in the numerator, and sin A over cos A would give us tan A, and sin B over cos B again would give us tan B, so we get tan A times tan B as the second term in the denominator. Well, this is the result we were required to prove. So this completes the proof and the question. Hey guys, Dwayne here. If you're a Caribbean student struggling with Cape Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching, and see you next time.